Okay, let's solve some leetcode today. Starting from least number of unique characters. So we have given an array of integers, and integer k finds the least number of unique characters after removing exactly k elements. Okay, remove the single for. Okay, so very simple. First we will calculate frequency by count r, then count array counter, sorry, counter. I'm not sure if Python a counter, if it does it have least common element in Python. I think most common there is for sure. Most common -1. Okay, yeah. So reversing string. Okay, so then we reverse it, and then we remove k. Python. Oh yeah. So removing k is like starting from k forward, right? And we then so after that we will have in a counter most common -1 k. Let's print it. So after that we will have we need to remove most common is undefined. We need to remove we removed k least common. So we have 544. So we have 5141, 5241, and we removed 1. We should have 41. But we are still removing 52. Why are we removing 52 if we are reversing here? So C equals C -1. -1 is the last one, right? We can sort it, yes. But we are not going all the way down, right? So reverse. Okay. Or we can say that we are removing so we can say we are removing, so if our most common elements will be C. So if we len minus K, this will be our result, right? Invalid syntax K must common minus K. And invalid syntax Y. Mm, Come on, so here is the 1 expected from 0 is a 3 output 1 expected 2. So in second example, we remove 4 and 2 because we have remove either one of the two elements, one or 3, right? So 3 is a 3, 1 is a left, so we can remove 4, 2, and either 1 or 3. So length of most common. And most common lengths. Okay, so we have 4 kinds: 3, 11, right? Because we have a 4 kind, we can remove 3, result will be 1. But we can remove elements, not elements from the counter, but elements from the array. Therefore, we cannot do this. MC, and what we can do, we can reverse so we can say for element in most common, we will be reversing most common from back. For that we have to sort frequency. Can I do least common, sorted, most common, and then lambda equal x. So we have minus x1. I don't think, oh, so we don't need the return. Okay, so we have to create dictionary from whatever we are searching, right? So this is why we have to have sorted, then we have to have items as a call, most common items. And then we assign key equal lambda. And then lambda is a function with a set x and return another key value, return value, and we create dictionary from that. List has no attribute items. Okay, because I jumped as a most common, but I don't have to. And see how it's going to find it. Okay, most common, least common is 4, 1, looks good. Now, for case 2, 4 is 1, 2 is 1, 1 is 2, 3 is 2. Then, if while we iterate for key value in our list count, what we're gonna do, we're gonna have k, or what we can do while k more than 0, and we have local index 0, and we can have list count. So we need to iterate through a list most common, least common. So we iterate least common, subtract least common, so k value, subtract value minus key equal key minus key value if key less than 0. We can only subtract if key more or equal value, then we subtract. Else but in this case, if we have a, okay, it could be a different problem in the future for future test. Else we break and we return, and then here, and also after subtraction, if we remove least common key, or we delete least common key, and we return length of least common. So we will be removing values that we iterate. Yeah, let's call this really quick for key value in least common if basically the same thing. We subtract, we delete, we break, we return less of least common. Yep, looking good. But the problem is that what if we want to delete? We should be instead of, for example, deleting two smaller and have them, it doesn't matter. Unpack them incredible object. While C is not incredible, it's a dictionary, right? I'll see. Yeah, it is dictionary. Do I have to do items? Only items. Oh, otherwise it will be key. Yeah, that's correct. Delete 3 key error key is not. Oh yeah, I have to delete key value, and it mess up with my key. So yeah, let's call this amount age. Change sender. I cannot change a dictionary. Oh man, so Rams. Then we add Rams append, and then for R in Rams, we delete list counter Rams. Here we go. Whoa. Man, okay, frequency count, frequency values, elements, OMG. I like my code better. It's kind of like shorter. It's not that fast for some reason. Maybe because I'm sorting it. Yeah, it's okay, I guess. So, hash divided string. Your given string has a length n. with integer k, where n is a multiple of k. Your task is to hash the string as into a new string called result, which is n divided by k. Okay, n is a length. For divide n by substring relative k for each substring order at the beginning. Okay. Calculate the sum of hash value in the substring. Find the remainder. Yes. So we sum of the hash values in the substring. Find the remainder of the sum divided by 26. Identify character English for reference. Character and of the result. So what we're gonna do? We're gonna do split string. Calc into array of strings for every called aus for every substring in aus. We calculate sum, right? So I wonder if you can go and instead of splitting, we can calculate sum. So let's say this: if we split string for every string substring in aus, calculate sum, and 3. I convert every we call it sum. Let's call it h sum or hash sum, and then for every hash sum I will convert every hash sum into character and append to the result string, and we return result string, right? So how about instead of splitting string, we will iterate for character in string, right? Then we will have to while we are inside of set, right? So for example, it will be relative position 0. While relative position less than k, we just we have to have relative position and we have to have a relative sum. While relative position relative sum will be I don't know, EDR. What is a way to convert char to int in Python? There is a function char to int. Come on, what's the name of the function? Python char to int. Okay, board. It's weird stuff. And char is back to okay. So running sum, we will add whatever we have character, or here we can say if running position is less than k, else running position more than k. This is time to calculate the same. What we're gonna do, we also have our result list, which will be list. Here, because we add in result stream, we have to calculate the result stream mode 27, I guess, right? So let's call it base minus base. Let's call it A, large A. I like it. So after we add in, and then at some point when we reach K, now it's time to convert it sum divided by 26. Reminder of the sum when divided by 26. So reminder will be sum divided by 26. Then we convert it into character. Then we call char on this, and we add it to result. And then we return join result. Yeah, looking good. No, when we reach this, we also have to reset running position, which is 0. And running sum, which is also become 0. It's not an error to impact. Okay, run result 0. And another 0 here. Okay, output is none. Very funny. So if running position is, and we moving running position to next one, right? Char is not defined. Hello, CHR, ONG, okay. What is this? Okay, so this is no. Back to string. CHR 97. Oh yeah. We have to when we adding, we have to A plus. Oh no. I think. Okay, I think it's good. But A plus, so I think this guy is okay. But let's add it anyway. And then we have to add this guy. Yeah, I feel like this is always the case. So we can say if LP more than key, then we do this. Otherwise, we always add I think I'm missing something like why it's G B F. Okay, key is 2. Okay, so calculate some hash value character in the substring. The hash value character index in the English alphabet. Calculate sum of hash values of the characters in the substring. Yes, okay, so hash value is, so I'm adding this guy. What have to do, like equal case? Okay, B, which is good, but why it's not giving me the last character? Yeah, because after the cycle, I have to do the same for reminder what is left inside the thing. Let's do the same. I don't have to reassign it, but I will end this guy. Because if there is a reminder, whatever is left, yeah. And done. 47. Oh, genius. Common people. Oh, this is smart. Minus 97, but I'm calculating 97. CHR count, okay. Pretty much the same. All right, next one. Invent binary tree. So we, given the root of binary tree, invert the tree, return the root. Okay, so if we have a root, we can call, we can say if not, we can say if root, right? We say that root left, swap with root right. Oh, it's not gonna work. Is it? So if not root, we will just return root. So if it's empty, it's not gonna crash. Otherwise, we return the same invert tree. Um, we return left part, so we right part, and then the end we return. Oops, I can remove this one to make code even. Come on. What is it? Alright. Inventory is not defined. Oh, have to call like south inventory. Oops. Yes. Easy peasy 100%. I should name like YouTube channel with this easy peasy 100%. I really like it. Okay, it's symmetric. For that we have if root left is symmetric. It's the same thing. If root and root right is symmetric. Given root point checks it as a mirror itself. Okay. So you see, if mirror itself, it means root left value. If root left value, if root left, and root right, both values has to be the same. If root and if right, we return we return root left value equal root right value, and but this is not the case. See how it is? We have to go. So if we have a 3, we return 3. So this we can tell, right? If two values are the same. But how we can tell if these two values are the same? If we call in 3, yes, so we have to go through left and right, like simultaneously. How about that? So we give as left and right positions, left and right ranges, and compare. So we have to do like DFS, but only on left. Then we do DFS, but only with right, and then we compare. I wonder what if I say like DFS um, left, right, and accept root, and it check if root left and root right. No, but you see the value as that it returns back. The value that it returns back must be but what if we say that going left first and going right first will be matching? For example, if I have array called left first array, right? And I will call this as root, if root, we call dfs left, um, root left, and dfs, and if not, we return root and dfs right. And here we append root well. And what if we have DFS right first? Yep. And what if we have DFS right and we go right first and then left after that? Right, and then we have left, and then we have right. And we return it, and we can print left array and right array. I just yeah, I cannot compare. Oh yeah, index equal same array. But I didn't call it, so let's call it. Yep. Wrong answer. Okay. Why it is true false use this case? What is this? I want to. Oh. So we go, let's print these guys. Print, okay, so we go test case. Ah. So it's not like nothing. I don't understand. So we go 1, we go 2, we go 2. Why there is a nothing printed? Left or right? For example. Oh, okay. They are the same. Output true. Why not the same? They are the same. Come on. They're... Okay, so this is the case. They are not the same because the number of given. So it both recursively and okay. So this is recursively. Oh, because it should be right, left, right. Yeah, so I have to add somehow. How about this? If else we return we append like some kind of symbol, or so we know that this is because it could be that we are not appending. Now let's see what it does. So here is else. Here is must have obviously the same. So it's right. Oh, twice. Left, right, right, left. But do I have to go to? Yeah, I have to go like this. See, I have 2, 3, 2, 3. They must be the same. Even if I'm going right first and this left first, like in this, right? First case. For example, we don't have this, right? Let's say this. Yeah. For example, like first test case, we go 1, so we go 3. Wait. So we go left first. we go left, left, and then we got 3, then we got 2, then we got 4, then we got 2, then we got 1, then we got 4, because we are always going left, and then we got 3. Right first will be 1, 2, 3, 3, we got back. But with this case, test case, we got 1, 2, left 2, and then if so, like this, it's still symmetrical, but it's not truly symmetrical. All right, it has been like more than 50 minutes, and yeah, and there is a follow-up question. It's really interesting task, and I probably should continue solving it in like, or start with it in another video. But we also have solved it recursively and iteratively, so it's probably BFS. For both parts somehow. So yeah, it's definitely that air quotes easy task. And yeah, well, I will start solving it in another video. Stay tuned. Thank you for watching. Take care. Bye.